it's always interesting to talk about quantum computing. It's fascinating to me, this thing called a qubit that can hold so many different states that they can contain within a single qubit much more computing power than our average computers do. So they've been working quite a while in getting these qubits stable enough to actually hold data. And once they can really substantially hold data, they can then go from that point to actually having a layer of programming over the top that can actually tell it what to do and what coding to run, and it can actually do work. Now, at this point, they're still working on getting the qubits to be stable. They've not actually got it to the point of doing any real work with the computers. So the quantum computer is still technically theory, but it's coming closer and closer to fact every day. So here's kind of an update on where the quantum computing is. This first report, of course, is more of a, quantum computer could break everything. It can get through all the cryptography. It can get through all the, all the security that we've got. Well, yeah, eventually it may, but they're also working on cryptography that's going to prevent what this author was concerned about at that point. So what he does is explain what quantum computing here is, and the fact that quantum computing can do a lot of work, and it's going to, in astronomy, chemistry, biology, all kinds of different areas. This is going to be a huge benefit to anybody doing research in those areas and needing massive computing power in order to get through the massive amount of data that they have to deal with. Okay, so let's look at the second article. The second article is about another group of people that's working on this, other than what this one is, just a general paper. I think he talks about Chinese researchers here. This group is over in Europe somewhere, yes, in University of Sussex in the UK. They're working on it, and they've got to the point where they can, I think they said they had a 400 qubit processor now that could transfer and keep, successfully transfer 99.99993% of the accurate data transferring back and forth. So what they're learning is a lot of good, solid data. Once they get this stabilized, then they can actually start programming on it. And then is where it's really, really going to get exciting. But what does that timeline look like? That's the key here is, what are we really looking at? We get a lot of teasing by some of these articles and a lot of, inferences as to what great things it's going to do. But let's actually see what kind of a timeline some of these companies are looking at, because IBM right now has actually published their timeline, so we can take a quick look at it. So I'm gonna open this up a little bit, and of course we're here in 2023. So last year at the end of the year in November, they showed their Osprey computer that had a stable 433 qubit processor, and that is quite incredible. They're expecting that over the next year, that by the end of 2023 and come to that same conference, they're going to be able to put together a single processor of 1121 qubits and then a parallel processor of 133 qubits times p, the number of processors. So they're already talking about extensibility with the idea of putting multiple computing devices together that can work on the same problems and work at it in a parallel sort of schema. Then 2024 they're looking at, so we're talking toward the end of next year, they're looking at a 1386 plus qubit system with crossbill being 408 qubits. So different technology here they're talking about. Details we could go into their articles, but that's probably beyond here. But see, what we're seeing is, let's look up here. 2023, they're starting to prototype quantum software applications. Okay? And by 2025, they're expecting the machines down here to be mature enough that they can actually run quantum software applications. So, such as machine learning.
Well, that was some thunder.
Wow. That was thunder, folks. Whoa, scared me out of my skin. Okay, machine learning, optimization, natural science, and finance. Okay, so quantum serverless, intelligent orchestration, and some of these terms I don't even understand at this point. Error correction comes out over here. They're talking about error suppression and mitigation in 2024 to 25, but beyond 26, they can actually have error correcting processors, which of course all of the Pentium and Intel class and AMD class CPUs have error correction in them, and we expect that. Okay, so the timeline really to get really excited about actually seeing deployable qubit quantum computers running software actually focused on applications is in the 2025 to 2026 timeframe. And I think that's cool. We can actually see light at the end of this tunnel that we've been trying to travel through for years. I mean, I've heard of quantum computing for 10 years. And, back when it was just theoretical and they were talking about the possibilities and they couldn't even get one qubit to work, and everybody was going, keep working on it, but I don't think so. But now it's actually becoming a surprising reality. Science fiction is becoming science fact, as we see so often. So experts estimate that it would take ordinary computers 300 trillion years to break an RSA 2048 encryption. However, Chinese researchers said in their paper that the encryption could be inversed with a quantum computer with 372 qubits, or basic unit of information acting as a proxy for computing power in just a few seconds, is what they said.
Okay, then.
We're talking about a huge quantum leap. Dare I say that?
Very nice.
Okay, so do we have? That would be crazy quantum machine learning. Yeah, it sure would. I mean, if we talk about, having a quantum computer and then miniaturizing it so it can fit in an Android sort of, humanoid sort of looking, robot. Mm-hmm. I mean, what could we get out of that? The machine learning there, the AI that was there, quantum gaming, anyone?
Mm-hmm. Well, yeah, just combine that with the very, very primitive AI we have today, and
it's gonna be
crazy.
Nothing at all.